So we look at the apparent velocity of winds and take this example, the first example in section 4F. A boy is running at 5 meters per second. So let's have him going in this direction here, which is positive I rather than the dot. So the boy is 5I, the velocity of the boy. The velocity of the wind is in the opposite direction. So the velocity of the wind, in this case 7 meters per second, is minus 7I. So the velocity of the wind relative to the boy, we know from previously, is equal to the velocity of the wind minus the velocity of the boy, which is equal to minus 7I minus 5I, which is going to be equal to minus 12I. And that's in meters per second. So it's kind of counterintuitive. If you're running against the wind and the wind's blowing against you, it's not like the wind is carrying you, so 5 plus 7 would be 12. But in this case, it's minus 12I meters per second, the velocity of the wind relative to the boy, not what would seem like 2 meters per second. So we look at the first example. When a boy runs north at 2 meters per second, the wind appears to come from the southwest. When he runs east at 4 meters per second, the same wind appears to come from the south. Find the actual velocity of the wind in terms of I and J. So in this case, we'll set up a couple of equations in X and Y, or A and B. And coming from the southwest is important here. So if it's coming from the southwest, we can see here that X is equal to Y, this 45-degree angle from the southwest. So that will help us further on in the question. When a boy runs north at 2 meters per second, so he's going in this way, the velocity of the boy is going to be equal to 0I, there's no I in the J direction, and then just positive 2J. The velocity of the wind, we'll start off by calling it X in the I direction plus Y in the J direction, or A and B, whatever letters you choose to use. So we'll form an equation, the velocity of the wind relative to the boy. Just don't forget your vector arrows. So it's going to be the velocity of the wind minus the velocity of the boy, which in this case is my xi minus 0, so I'll just leave it at xi. And then we have plus y, this y minus the 2, so y minus 2 times j. Now we can say that x is equal to y minus 2 at this point, but let's form our second equation based on the second scenario that they're giving us here. So when he runs east, so he's going in this direction, positive I, the same wind, and it's 4 meters per second, so the velocity of the boy in this case is just going to be 4 in the I direction. The same wind appears to come from the south, so the wind is now coming from this direction. So coming from the south, there's 0 in the I direction. So the velocity of the wind, we start off, it's going to be same wind, so it's xi plus yj. We can have the velocity of the wind relative to the boy now. So it's going to be x minus 4 in the I direction. Just move across here. We just have just y in the j direction plus y in the j direction, not j, y in the j direction. It might be easier to use a's and b's. So in this case down here, in the first case, we can say x is equal to y minus 2 because it's coming from the southwest. X is equal to y minus 2. In this case up here, we can say that x, there's no I, so x minus 4 is equal to 0, and that was because the wind is coming from the south. This is the case 2. So here we can say x is equal to 4. And if x is equal to 4, 4 is equal to y minus 2. So you can see here that y is going to be equal to 6. So the velocity of the wind, which is equal to xi plus y times j, has to be equal to 4i plus 6j. Nice easy questions, kind of simultaneous equations, but a little bit of knowledge about southwest, southeast, from the south, from the north, and so on.